This topic on matrices, we will be starting off with what is matrices. Basically, this topic is very isolated. You will not see much of this in other topics. So when this topic appear during exam, if it's in paper 1, it will be a very short question. In paper 2, it will be a story sum. So sometimes the story sum can be like between 5 to 8 marks. Okay, so that is the approach that basically we will use for matrices. It's an isolated topic. It doesn't affect much to the other topic. So what are matrices, right? So matrices are a set of numbers that we're going to arrange in a rectangular manner so that it can look very different. So the numbers within the matrices are called elements. Sounds a bit like sets and Venn diagram. Okay, so the order of the matrix is determined by the row and the column. So for your information, row is horizontal, column is vertical. So we use the row and column to decide the order. So sometimes during exam, it can be as simple as what do you think is the order of this matrix? So where we will describe the order of a matrix in a row times column manner. Okay, so for example, something like this. So you see a bracket. So we actually contain all the numbers in bracket. So like sets and Venn diagram, we put all the elements in curly bracket. So in matrices, we put the numbers or what we call the elements in a bracket, round bracket. There won't be square bracket for matrices. So like for example, 1A, 1 row, 3 column. So it is a 1 times 3 matrix. 2 row, 2 column. So this is a 2 times 2 matrix. Okay, 2 row and 1 column. So this is a 2 times 1 matrix. So if let's say if you just have a number like this is called a 1 times 1 matrix. So that is the smallest matrix that we will have. So you always go by row and column. We will not be doing column and row. So you gotta get the order correct. It's a standardized order. Okay, and why do you need to know the order of a matrix? Later on, in one part of the matrix multiplication, the order of a matrix will matter. So you must be clear about the order of a matrix. So later you will practice your sets A on the order of matrix. So I'm going to introduce you some terminology. So basic terminology will be something like zero matrix. So zero matrix will be a matrix where everything is zero. So if you look at this, right, it looks like, can you see that it's bold? Can you see that this 0 is bold? It's in bold print. So it actually means something, it can be like this one, it can be like this, it can be like this. It can come in a lot of shapes as long as everything inside is everything inside is 0, then we'll call it a zero matrix. So like I mentioned here, it can be in any order. Okay, a square matrix, right, will have the same rows and column. So it behaves like a square. So like the 1 times 1 matrix, where there's only one number, 2 times 2 matrix. 2 times 2 matrix will be quite common. So this is a 2 times 2 matrix. 3 times 3 matrix. Okay, 4 times 4 matrix. In O-level syllabus, we don't actually go beyond 3 times 3. Okay, if you progress to JC, then you will have bigger matrix. Yeah, and one of the things that will be easily forgotten will be the identity matrix. So identity matrix is quite important. So it has a special function. And it is a square matrix. So this is one of the first condition. It is a square matrix. And then the elements in the leading diagonal. Leading diagonal are the diagonal going on the right side, in the right direction. So the feature of an identity matrix will be the diagonal has element 1 and all other elements are 0. Can it be the other diagonal? No. So in case some people will think that this is an identity matrix, it is not an identity matrix. So there are some questions they may ask you about identity matrix. Later on, we'll look at the kind of question after you know the basic operation of matrices. Okay, so here comes the more technical definition. So we will have equal matrices. So the condition where we consider matrices to be equal is when they must be the same order. So in the same way, something like same size. And then the corresponding elements are the same. That means the matching of the element are the same. Okay, so we match the position. Okay, so because of this, they can introduce different algebra, and sometimes it may even lead you to simultaneous equation or quadratic equation. So a very simple example of equal matrix will be, so if you can see this is a very small matrix, 2 times 1 matrix. So when we say that these two are equal, right, that means the top elements are the same. So the top elements are the same. And the bottom elements are also the same. Okay, so this is a very simple comparison, but sometimes they can come out with a very complex one. So imagine you got 2 times 2 matrix equal to another 2 times 2 matrix. So you got 4 elements that you can be comparing. Something like this one. So if you take a look, P is equal to Q. So which means, right, 2A, 12, 10. So it will lead you to certain formats of equation. So if you compare this and this, it's actually quite simple, but it can also be very subjected to careless mistake. So we compare the corresponding one. In a way, we compare based on the position. No other way of comparing. So that is what we meant by equal matrix. Technically, that's quite easy. Just don't make careless mistake. So the first part that I'm going to introduce on matrices are actually quite simple. So we come to the addition and the subtractions of matrices. Addition and subtraction is also very easy. So it can only be done when the order are the same. So in a way, again, you need it to be same size. The reason is because we are adding the corresponding element. So we are adding based on the position. So if you take a look at this one, it's a 2 times 2 plus 2 times 2. So I'm adding on based on the position. So here, this is the one that I'm adding on. So some people may like to use highlighter. So I leave it up to you. So we add according to the position. Okay, not enough color. So you will get minus 2, 14, 7, and minus 17. So this is not needed. You don't need to show this working. You can mentally add them up. It's just that if you are worried that you will make careless mistake, then maybe you got to write it down. So for subtraction, it's the same thing. We are subtracting based on the position. But subtraction will have more chance of careless mistake, especially when the element is negative. Because, for example, in this case, for this part, there is a double negative because you are doing the operation subtraction. So you are subtracting. So you will have a double negative. So during matrix multiplication, there is a higher chance of careless mistake. Otherwise, it will be quite simple as well. So whatever is it, when you add or subtract matrices, you will be doing it with same size matrices. Okay, so sometimes the operation can be a bit more challenging like this, but it's not really very challenging. It's just that you are dealing with a lot of numbers. So if you got three matrices and you are worried that you will make mistake, my suggestion is you will do the first two matrix. You'll find that maybe your brain cannot process 3 steps. Okay, I wouldn't do one shot. I'll be worried that I make a careless mistake. Something like this. So you might want to, okay, so for part B, right, there is an O here. So in case you're wondering what is the O, so that is the zero metric that we were talking about. Okay, of course, one of the possible mistake will be sometimes you copy the wrong metric. So this one, you're adding a zero metric. So essentially, it doesn't affect much of the answer. And again, we can be doing some solving with addition of metric. So they say R plus P is equal to F. So you got to do the addition first, then we apply our idea of equal metric. So here is more like applying the idea of equal metric. So if you're applying the idea, right, if this is the equal metric, so these two elements there's no algebra, so these two must be the same. So these two must also be the same. So if you work out somehow the number doesn't match, that means you might have made a careless mistake. Then from there, we do the comparing. So we compare based on position. So essentially, it's very easy. So that is one of the basic operation. Another more examples on matrices. Sometimes you might feel that in this kind of addition and subtraction of matrices, it behaves like algebra. So for example here, to me, it feels like it's algebra. So I'm going to shift this addition of matrix over to the other side. So then I will do a subtraction. So you can shift the matrices in this way. Then I will get 10, 11, 5, and minus 3. So same for part B. Okay, N will be this. Subtracting the other one. So to me, it behaves a bit like algebra. Then I do my subtraction of matrices. So again, be careful because you're dealing with a lot of numbers. So if your eye, you miss the number, your eye may be doing a subtraction of a different number. So 11 minus 4, 6 minus 7, 5 minus 3. Okay, can see whether it does match. 5, 3, 4, 10, yeah, it match. Okay, so there's a bit of like behaving like algebra in matrices.